Okay, so last class, I introduced the words domain and range. Domain is a way of describing what are the x values for the graph, these values. The range was what are the y values for the graphs. Right? And we just say, hey, what's the lowest value? What's the highest value for x? And they're all in between there. Okay? We had different kinds of endings to our lines. We had solid dots, we had hollow dots, we had arrows. The solid dot meant that, where did that go? That is not right.
That's a long time ago.
Yeah, it just jumped.
That was like 4 months ago.
It's a sign.
Oh.
Oh, yeah.
Yeah.
So the solid dot meant that the point was included. And the way we identify that on our set notation is with the square brackets. Right? The circle one meant, hey, the line goes all the way up to here, but this point is not included. The way we identify that on our set notation is with round brackets. Right? And when we have a graph going with an arrow, it means it goes off forever. In mathematical sense, that means going towards infinity. And since you can't never reach infinity, we do round.
The sideways 8.
The sideways 8, yeah. Okay, so we're gonna, I think we should start on the back side of the page. We'll do more set interval notation, and we'll come back and do the interval notation, sorry. So to begin with, we're going to do the same thing. There's two types of notation. So please, under, not the dot one, but anything with a solid line. So these 5 graphs, divide this space in half. For the left side of the space, write down the word set. The right side of the space, write down the word interval. Set, interval, set, interval, set, interval.
Almost done.
All right. Okay. Yes.
I wasn't here this class, so I don't know.
Copy them. You'll learn as we go along. Right? So just words, set and interval. All right. Okay. So we want to be able to describe what is the x values for this graph. That's with the letter D for domain. And what are the y values? We use the letter R for range. So we're going to start off with talking about the x values. We start off with what is the smallest x value that we have on the graph, which is the furthest to the left. What number are we at the furthest point of this graph?
-3.
Yep. So we are here. This is at -3. So we put a -3 in. Then we go, what is the furthest to the right? What is the biggest x value we have on the graph? So going this way. The graph.
Positive 1.
Yeah, so that's right here. We do a positive comma, positive 1. Okay. So now, we need to include brackets here if the -3 is a part of the graph. So if it's a solid dot or a line, it's included. If it's a hollow dot or an arrow, it's not. So here we have a solid line. The graph can be the value of -3. So we give this a square bracket.
Same with the others.
Same with the other one. All right. Now for the range, we do the y direction. What's the lowest value? That's the one we start off with. So at the bottom of the graph, what is the lowest value of y we can have? That's right here.
-1.
Yep.
2. 1. Sorry.
Yep, -1. Oops, draw -1, comma. Then the highest value of y we can have.
+3.
+3. And
Square
since
brackets.
these are all solid lines here, this is going to be a square bracket. Okay. Hopefully this is coming back to you. Okay. We're going to do the same thing now for this graph. So I've shown you all the different kind of variations that we're going to come across. For most of these, I've hand-drawn the graphs. So if the number doesn't look like it's perfectly at a number, that's just because I kind of rough drew it in there. So for the purposes of these domain and range, everything's always going to be at a whole number, either positive or negative, right? I'm not going to ask you for 2.5 or something like that. All right, so domain, x values, smallest x value on the graph. So furthest left, how far can we go?
-2.
Yes, that's right here. We are at -2. Comma. We go, how far right can we go? We're sitting right here. That's the furthest the graph goes. We have an arrowhead.
So it'll go forever.
It'll go forever.
Sideways 8.
Yep. To in the positive x direction.
Sideways 8.
Sideways 8 for positive infinity. All right. So now, time to talk about brackets. At -2, we're over here.
So we got a square.
Square bracket. For infinity, what do we have?
We have a circle bracket.
Circle round bracket. Because we will never reach infinity. All right.
Only I will. Just that special.
Oh yeah. Well, we should start calling you Buzz, right?
Yeah.
To infinity and beyond. Okay. Now range. We go to the smallest value first. So we hit the bottom of the graph right here. We have an arrowhead. So it means it's pointing down
So
forever.
Sideways 8.
Well, sideways 8 would mean positive infinity.
I mean negative sideways 8.
Yeah, so it'll be negative infinity. So we're going down forever. That's in the negative direction. So it's negative infinity. So that one will be negative infinity. Then we go to the top of the graph. And we have this arrow sitting here. And it's pointing up to the right forever. So it's positive infinity. There we go. All right. So now, brackets, since they're both infinities, they get round brackets. All right.
You almost be the teacher here.
Yeah, you're getting it.
Yep. You're gonna have to sit down.
Oh, it's jumping on me.
Is there something wrong?
Yeah, I may have to just restart my computer. It's been a week. All right.
You might just have to get a new one.
Maybe. All right. One glitch. It's time to get rid of it.
Yep. That's what I do.
All right. Domain. How far left can we go? What's the smallest value? So you go to the left edge of the graph. We have an arrow sitting here. So what direction is this pointing towards? Emily.
-4.
Negative.
Nope. It's at -4, but the arrow means it keeps on going.
Negative sideways 8.
Yeah. Negative infinity. Thank you. And let's just do brackets at the same time. What kind of bracket does negative infinity get? Square or round? Round. Thank you. Then we go to the right. And how far right does this graph go? Right? This is the maximum distance this way. That's the maximum value of x. What number are we at?
+2.
Yes, thank you. And does that 2 get a square bracket or a round bracket?
It's a round bracket.
Thank you. Gets a round bracket because we have a hollow dot. That means this point is not included. All right? All right. Next up, range. Looking for the bottom of the graph.
Negative infinity sideways 8.
Yep, we're at the bottom of the graph. We have an arrow pointing down. So it's going to negative infinity. Now, we're going up to the top of the graph, not to this end point of this line. We're looking for the maximum value y can be. That would be up here. What value are we at?
That would be 4.
That is 4. Square or round bracket?
Square?
square. We have a solid line there. We can achieve the value of 4. So we put down a 4 here, meaning that 4 is included. Sorry, the square bracket, meaning the 4 is included. All right. Next up is this one. Boy, nice and quick. That's good. How far left can we go for x?
-5.
-5. We are looking at this point right here. What kind of bracket does that point deserve? Square or round?
Square.
Square, solid dot, square bracket. Comma, we go to the right. We go to the max end of the right. We're sitting at this dot here. What is the value?
4, but there's a circle, so you have to do a circle bracket.
Yes. 4, open, perfect. There we go. On to range. We go to the bottom. One first. We're sitting at this point here. What is the y value and what kind of bracket? Aubrey?
Square.
It's a square bracket, and what's the value?
Negative.
Yep. This is the value here, -4. So -4 with the square bracket. Okay, now we go to the top value of y. The maximum value. We're sitting at this point here. What is the y value and what kind of bracket?
Circle.
Circle, and what's the value?
4.
Not 4.
2.
2, because that 4 is the x value. We're looking for the y values for range. 2, with the round bracket. There we go. All right. Next up, domain. How far left can we go? That's my left edge of the graph. So yes, thank you. -infinity, and that deserves a round bracket. I go to the right edge, and I'm putting this symbol here. So what do we write down for this one?
Infinity.
Infinity, because it goes right forever. All right. Range. What's the lowest value this graph can be?
1.
1. What's the highest value this graph can be?
1.
So the range is just 1. And since it can equal the value 1, which is a solid line at there, we give it square brackets. Right? So it goes here. Doesn't go any lower than 1. Doesn't go any higher than 1. Stays at 1. And it can equal that value. So square brackets. That one's a little bit kind of an oddball.
What do
Okay.
you do with the interval thing now?
Yeah, now we're going to go right back to the beginning.
Oh, yeah.
And we're going to do interval. Okay. So now with interval notation, we use inequalities to say the exact same thing. All right, so we use our greater than and less than symbols. Okay, so we use these symbols. All right, and or we use the exact same symbols with an equals line. Right? Because this means bigger than, that means bigger than and equal to. Right? So we have two situations. We have square brackets and round brackets. Right? When we want to include the point, which is a solid dot, or square brackets, we use the equal sign. Because it wants to equal that point. Okay? When we have an arrow or open circle, we can't actually equal these values, so we use these ones, because this means greater than or less than, but not equal to. Okay? So our endpoints don't change compared to what we did for interval notation. So to do these, here is the format. Write down domain, keep the same endpoints as you came up with your set notation. So -1 and 3 here. So we go -1 space x space 3. For range, it goes -2 space y space +2. So we're going to keep the same endpoints, right? We put the x and y in. This says it's x values. This says it's y values. Okay. So now we need to talk about inequalities, right? So now I'm going to suggest that when you're first setting up your statement like we just did, we put these in. And then the only decision you have to make is, do you include this after the fact? Right? Because all of them are going to have an inequality symbol. Some of them may have an equal sign. Some of them may not. That we can tell by what kind of dot we have. So when you're setting these up, go like this. All right? Every single time. All right? So if you always put the smallest this side and the biggest this side, this symbol is always going to be opening the right way, opening to the bigger number that way. Right? So if you keep that order, you're not going to have to think about it. So now, the only thing you have to think about is, do we include the equal sign underneath this symbol? So here we had a square bracket and a solid dot. So that point was included. So we put a little equals line on there to signify that the point was included. The same thing with this. This 3 is a square bracket and also a solid dot. So we include, that point is also included. Right? And same thing here. Square brackets deserve or get the equal lines. Right? So now this is just another way of saying the same thing. This was a shorthand. This is a little bit longer hand. But this says, hey, the domain are the x values, and they range between -1 and 3. And x can be -1, and x can be 3. And the same thing for the y, okay? So let's do this one, okay? We set up it the exact same way. The end points are there. Include your inequalities. Right? So I'm going to take my numbers from here, put them down there, take the numbers from here, put them over here, put my x and y in the inequality symbols. Okay? Then after this point, once you have that written down, you're just going to decide whether or not to put the equal sign in or not. All right? So I'm going to grab my orange marker here. So for -1, here on the x, we have a square bracket. Does this get an equal sign? Yes, because that point can equal it. Okay, this 3 sitting here, and up here we have an open bracket and a round thing. Does this 3 get a equal line? No, because it can't equal it, so we leave it out. Next one, the -2. Does it get an equal line? Look at the bracket. I find looking at the bracket's easiest.
Yeah.
Yeah, it can equal it. +2. Can this get an equal line? No. Okay. Done. Okay. Quickly do the next one. I'm sure you guys could probably do it very fast, probably faster than I can write it. I'll write it and I'll talk to you guys about it. Okay. Which ones get an equal sign here? None. Because they're all round brackets or open circles, right? So none of them get it. Okay, on to the next one. we set it up the exact same way, right? So we have our domain, we have our range, right? Okay, I'm going to ask you, where do we put the equal signs? Right, so we're just taking these numbers and putting them over there. Okay, -1 here. Does that get an equal sign?
Yeah.
Yep, we have a square bracket and a solid dot. Infinity, does it get an equal sign? No. -2, does it get an equal sign? Yeah. And infinity, once again, does not. Now, if you wrote this answer down, I'd give you full marks, but this is not the answer I want to see, right? This has redundant information. So if you are looking at the back of the book, you saw the answer, it would look like that. That infinity part wouldn't be there, right? Because we can say x is bigger than -1. It doesn't need to have the infinity bound, because this means it goes on forever this way anyways. So that writing that infinity part here is redundant. So if you see infinity, do not include it in your interval notation, right? Because this is saying y can be bigger than bigger or equal to -2, right? Bigger is this way. You don't need to have an upper bound to stop it. So that infinity part is not necessary. Okay, is that okay? All right. So,
Can I go to the garden?
yeah. Okay, I'm not sure if we need to do every single one of these.
Let's do the first two.
Let's pick. I want to talk about a few of these. Let's do this one here. Let's do this one here. All right. All right. You see an infinity symbol? You don't need to include it.
Okay.
All right. So, but keep the order the same. Infinity was supposed to be on the left-hand side, so we're going to leave that part blank here. Then this can be the x. Then we're going to put the number 2 down. Right? Infinity is supposed to be on the left side. We're going to keep that blank. Then we're going to put the 4 down. We're going to put in our inequalities. And we just need to make the decision of whether or not to include the equal sign. So looking at for the 2 here on the x, no, because we have a round bracket and an open circle here. The 4,
Yes.
yes, we have a square bracket, meaning a solid line here, so that needs it. There we go. All right, now let's do this one here. So domain and range. Okay. We don't include the infinity. So for the domain, we have -2 x like this. Do we need to include the equal sign for that -2? Yes, we have a square bracket and a solid line. Okay, now I just finished saying, hey, if there's infinity, we leave that out, right? So this one's got infinity here and infinity here. We can't just leave this blank, right? So in this situation, since this graph can go forever down and forever up, it's all the possible values, all the possible numbers. So the way we say that is all the real numbers. Okay. So instead of writing infinity to infinity, we say all the real numbers. So we have whole numbers, we have integers, right? We have something called real numbers, which are all the different kinds of numbers that you can have. And when you get out of high school, you'll learn about imaginary numbers. So if you're taking any science courses or engineering, maybe even some business applications have imaginary numbers in there as well. Okay? So, infinity to infinity, all the real numbers. All right. The next one I want to talk about is this one. So, domain. What do we write down? All the real numbers. Range. Right? Since we don't have a range of numbers, our range can only be one number. So we just write down y is equal to the value of 1. Right? This is not less than 1, it's not greater than 1. Y can only equal 1. Okay? All right. So now, there is only one type of graph that we haven't talked about. That's with the dots. So I think that you guys understand these. We don't need to do every single combination here.
Nope.
You guys get that? So go back to here. We're going to talk about the dots. Okay. Now, the way we've set this up so far is we give the lowest value and the highest value. So we say the x values are between -1 and +3. And the way this notation, what it says is every single value of x in between these two bounds exists. And you look at it, yes, there's a line here. I can read off a value of x for this graph at any spot I want to in between those two numbers. Right? That's what that means. It exists at every single spot. Now, when we have dots like this, we can't do that. Because here's the left bound, here's the right bound. If I wanted to look up a value right here, and go down to the graph, there's empty space. I can't read that value. It doesn't exist. So we need a different style of notation. And this is where we have lists. So this is used for just dots, no lines. And we just list the values in a different kind of bracket. So we have square brackets, we have round brackets. Now we introduce curly brackets. Okay? And inside these curly brackets, you just list the values. Okay? So if you're talking about domain, we list the domain values. If you're talking about range, we list the range values. Right, so let's go to this first graph here.
Just 1 second, I gotta give you a pen that one.
Okay.
It's not good.
Okay. So for this graph, I want to know what are the x values. Right? So that's for domain. The x values of every single point. What is the x values? And we just list them. So we start from the smallest to the biggest. We work from the left side to the right side. So here, x value here is -1. So I write down -1. Comma, I go to the next point. X value here is 0. I write down 0. Then I go over to the next one. The x value here is 1. So I put down 1. Then I go to the next one. I'm at 3. So I put down a 3. Oh, sorry, the 2. Then I go to the 3. And once I got everything listed, I end it with a curly bracket again. And that's it. Okay? Then for range, we do the same thing. But this time, instead of looking at x values, y values. And once again, we go from smallest to biggest, left order. So we start from the bottom one. What is the y value here?
-2.
-2. Then we go to the next dot, which is right here. What's the y value here? Yes, it is. Then we go to the next one. Where are we at? Nope.
0.
0, the y value, right? The next one right there, what's the value? 1. And this one here, thank you, 2. We've got all the points listed. We finished off with the curly brackets. And that's it. Okay? So one more discrete data graph that's over here. It's pretty straightforward. I want to talk about I'll quickly list the domain. So doing the domain from left to right, this one's -3. Next one over, we're at -2. Next one over, we're at -1. Next one over, we are at 0. Next one over, we're at +1. Then we're at +2 and +3. Okay, so these lists can get quite long. Right? I know the domain on this one is very similar to what we did last time, right? But the range is different. We have a different situation for the range happening here. So range, we're looking at the y values. And when we look at the y values, starting from the smallest to the biggest, is at the bottom here, we have 2 dots. Both of these dots are at y value of -1. You do not need to list -1 twice. Only list it once. So that is at -1. Right? Both of these values are -1. Then we go up to the next set of values. Right? Those are at 0. Then we go up to the next set of values. Those are at +1. And the third set is at 2. Okay? So when you look at this, your domain has a lot more numbers in your range, and that's fine. Because we don't repeat numbers in these lists. And that's it. Okay, so we'll stop right there.